Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Picture, maybe I will just look for the page. So VPC AWS image. So if we say AWS VPC, better image on this. Okay, so that's how the virtual private cloud, ideal virtual private cloud looks like. Let me drag an image over here. So I have one. So if I go to all, drag image for you, GitHub. Okay, I believe I have an account and I have a good image over here. So learning wiki, I'll take you to the very good image on this cloud security. There's a good image over here. This is a bunch of good image which you can see over here. Okay, so see, this is how the complete VPC looks like. A ideal VPC should look like. So you have a VPC with public and private, all instances. You create a public subnet and then you have instances into it, all the instance security group, your security group attached picture, and then you have route tables and you have router which takes you to the internet gateway or a virtual private network or a virtual private gateway. Okay, so when you create a VPC, right, you get the you'll have to when you create a VPC, you'll get the network SCL, you'll get the route tables, and then we create a security group. And in the security group, we mentioned that what traffic has to be taken, or which all ports which will be open on the instance, and all those ports are being open for what all will that be open globally, or will that be open to specific IP address. So security group over here is moreover nothing but talks about is your firewall, right? It's a security group is your firewall, which you can think of a soft firewall, um, or your host firewall, which you can think of. So it's a host firewall which takes care of completely completely all the traffic which will go out, ingress and outgress traffic which will go out, and what will come in. So that's that security group is. And then you have network ACL before. So network ACL is somewhere where you wanted to, let's say you wanted to block a public, IP address, or any IP address you wanted to block on, so that it should not reach to this instances on public or private. So that particular kind of stuff, you do it on the network ACL. And before network ACL, there's a route table. Route table decides where, as it names you, the route table, it decides where to take the traffic on, whether to direct the traffic to public or we direct the traffic to the private subnet. And both of the route tables connects with the internal router, and router connects with the internet gateway. Okay, so that's how this VPC of public private subnet has been created and actually works in this way. Whenever you create VPC, you will have this security group created automatically for that. You will have network ACL created automatically for that, and you will have route tables created automatically for them. Then we have to create a if you wanted to segregate them, we have to create a different or two different subnet, and on the different two subnet we work on the subnets in order to to separate or segregate our instances or services which you want. So let's say this is a public subnet, this is your application which you wanted to expose to the world, and this is a private subnet where we wanted our instances not to be exposed to the world. Okay, so similarly, if you wanted to really create it, what you can do is you can go to your AWS account, you go to services, here you go to VPC, okay, you click on that. Okay, so we are going to implement this particular whole chart which has been over the complete picture and image which has been over here. We're going to maintain that and create it on this. Yes, Kanan.
Hello, Vasant.
Kanan, can you hear me?
If you don't mind, yeah, I can hear you. If you don't mind, can you share your mobile number in the private window? Hello, Vasant.
Yeah,
Am I audible?
I will call you back. Yeah, I got your number. I'll call you.
Yeah, yeah,
Do you want me to call you right away
yeah,
now?
yeah. Thank you.
Yeah, you're audible.
No, 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 not
You want
now.
me to call
When
right
you
away,
free?
or you want me to call at 1?
No, no, no. 1 o'clock. When you free, you call
Okay,
me.
I'll give you a call at 1 o'clock, right?
Yeah, yeah, yeah.
Yeah, I'll give you a call back.
Yeah. Okay. Thanks.
Okay, on the VPC, you see that there's a VPC sections, and then there is a launch VPC wizard. When you click on that, okay, so it takes that what you wanted to do. Oh, now it gives you much more flexibility that you can have a structure automatically and private subnet and hardware VPC access. So if you select that, it's going to create a template for you. This is good. Before we have to create a VPC by our own self, we have to create a public subnet, we have to create a private subnet. But now they have given you this flexibility that you can select any of the template model over here. If you say VPC with a single public subnet, it's going to create a VPC with public subnet. If you say with public and private subnet, it's going to create a public subnet and private subnet for you, and that's really nice. And if you say with VPC with public and private subnet and hardware VPN access, I don't want VPN access for now. VPC with private subnet only and hardware VPN access, no. We can have a VPC with public and private subnet. Wow, that's really cool. They made a change into this service, and I was not a bit aware of. I'm not sure whether they made this change within a week or so.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Because it was not there within last month, but yeah. So they made a change, which is good. When you create a VPC launch wizard now, you will be able to create a public and private subnet automatically. This will create it automatically for you. That means this picture over here, which we were looking on. Okay, so yeah, so then nothing to talk about. We don't have to worry on this, but we just let me take you to the chart now with this. Okay, select this wizard and we'll select this. What will happen? We will have a complete implementation of this diagram. We'll have we can later on include our instance, and that instance, when it goes to a private subnet, will not be able to go outside and cannot be able to access the internet. Okay, and then on a public subnet, we'll have an instance which will be able to access and go outside. There will be in all the traffic of public can come into, and the instance can go outside to take the internet. Okay, so internet will be enabled over here, not on this private subnet. So when as it was a wizard, now we have everything over here been created, but before, when there was no wizard, we have to create a public subnet, and to make sure that the traffic is going out and our public subnet is will be able to have a internet coming in, and our instance is able to go outside and have an access to an internet. what we do is usually we create an internet gateway and we attach an internet gateway to our public subnet. In private subnet, we don't attach an internet gateway, but there will be a chances or there can be a need where your private instance wants to go outside and get connected with the internet, but they don't want to have a traffic coming inside. Okay, so what happened in those situation? Okay, so what happened in those situation is, let's say I have a MySQL. Okay, this is an instance which have a MySQL. Definitely MySQL or any database service, definitely they wants to update if there is an update available online. And if in those case, if my instance is not able to go outside and update itself because there is no internet, there can be an issue, right? So we want our private instances also to access the internet, but the traffic should not come in. Okay, in that case what we do, okay, if you want inside and outside internet to come in and go, we use a, in a private public subnet, we use an internet gateway to to have that. But in a private subnet, if you want only the outside internet should go outside and should be able to access the internet, then we use a NAT. Okay, NAT gateway. Okay, so an NAT gateway allows your instances, private subnet instances, to go outside and access the internet, but do not allow the traffic to come in and access the private instances. So NAT gateway was the one which we use, which we preferably have to create in order our instance has to go outside and access the internet. But on the public subnet, we always when we create a subnet of public, we always attach an internet gateway. That's how we make that it's a public. And security group over here, it's a host based firewall you can think of, which allows the network to come in and go out on the basis of the ports which you open on the security group. Okay, then you have a network ACL and behind. As I said, it's basically the first layer of taking the traffic to come in or go out or not. In this, both of these are, you can think of a quite similar, but network ACL comes first as for when your traffic goes route into a particular subnet, it comes first. And in the network ACL, we can easily disable the IP addresses which we don't want to come in and access the traffic. Similarly, like there's no network, network ACL is there, and if you, like, from the security point of view, if you get a requirement and saying that, hey, block this IP address, so blocking of the IP addresses, you will do it on network ACL, not on security group. Okay, if suppose in your in a security, as a security engineer, you will have to see, or you will have to check that in a security group we are not opening a port unnecessarily for everyone. Like, there should not be a CIDR block saying that 0.0.0.0/0 on some ports. Like, for example, 21 port, 22 port should not be open, 22 port 21 port should not be open, 3389 port should not be open publicly. That part you will you will do it in your security group, right? So accessibility of the ports on the whether it's been allowed for the outside world or not, that you will do it on security group. In security group, we have, in both of that, security group and network ACL, we have ingress and outgress, or inbound and outbound, you can say it, or ingress and outgress um, rules. And in network ACL, though it is a stateless, so you will have whatever IPs you want to block it and in, you'll have to also block it on out. But in case of security group, it's a stateful. So it's a stateless and it's a stateful. That's a difference. And it comes first. Any IP address you wanted to block, you will do it over here. Any port you wanted to not allow to the world or something, so that's a host level firewall you can think of. Okay, which actually allows the port fill, whether the port, um, like, you wanted to open this for the public or not, you wanted to open it only for the specific IP addresses. Let's say you have a instance over here which you wanted to open only for your organization, so you will write the IP address of the organization where you wanted to open it. So allow list always will be on the security group, block list always will be on the network ACL. That's it. Okay, so this is how it looks like. So now we have a wizard, and if we select private and public subnet and we select that, okay, so it's gonna give you a, okay, I'm gonna use it's gonna give you this, okay, no IPv6 is allowed on this. I would say no IPv6 is allowed, block owned by me, Amazon provided IPv6. No IPv6 would be good. VPC name you can give it over here, and this is a one subnet CIDR block. This is a public subnet which will have this as an IP address. This will be availability zone. If you want an availability zone, you can think of. Okay, then this is our public subnet. Then this will be a private subnet. If you want an availability zone where it should be created, you can select that. Okay, and then elastic IP NAT gateway, which will be which will be required so that your private subnet is able to access as I said, outside your outside network should be allowed. That's why we need a NAT gateway, and NAT gateway will be a subnet automatically. That's really great. And once you write your private VPC name, it will automatically create route table, network access control, security group, and it will create a two subnets. One will be a public subnet, one will be a private subnet. So the next time when you launch your instance, you will select this VPC, okay, and you will select the particular subnet where you wanted to launch your instance, and that particular instance will be launched on that particular subnet. It's really, they made these things very easy now. So VPC name is, let's say I would name this as VPC Sony Day 3, and we need a NAT gateway, as I said, because NAT gateway is required, and there is no elastic, and this has been required. I don't have an okay. If I don't have elastic IP, that's found. Please alter your search. We have to create a NAT gateway first. So let me create a NAT gateway. VPC. Okay, we need a NAT gateway because NAT gateway will to go outside and access the internet. All right, so we will see first a NAT gateway. Do we have one? So there's a NAT gateway on this. Okay, so we don't have one. Okay.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, we are here. My Sony demo day 3 NAT. Okay. No elastic IP. Okay, I think that can be one of the issues. Specify location, private subnet. Let's just create this, okay? Let's create VPC. Invalid location IP, the location ID that you entered must not match of an existing IP. Okay, let me write any NAT test. Don't have an elastic IPs, we need that. We have to create one. Select any subnet. Allocate elastic IP. So actually we need an elastic IP to do that for the NAT gateway, but why it's not allowing me to do that? There should be one point which should be allow me to create a NAT gateway. Use this. Okay, and then create a VPC. Click on this. Okay. So it's gonna create us, a complete VPC which is subnet. One is public and one is private subnet. And we'll have a NAT gateway attached to our private subnet, so that our private subnet gets the traffic outside some period of time, and picture diagram which we saw over here. Okay. Okay, so meanwhile it's getting created. I'll tell you 2 or 3 terms more on this. So we know now what NAT gateway can do. Before NAT gateway came into a picture, there was another option we can have it besides from NAT gateway. That was a NAT instance. Okay, we can have NAT instance also. Can also take a traffic outside to the world over here, which can work, but NAT instance, as the name shows you, it's a NAT instance. So that will be an EC2 machine again. So that that NAT instance, because it's an EC2 machine, then we have to take care of the NAT instance as well. We have to make sure that it has good configuration, that that is a it has a good configuration, that it can take our network, you know into a it has a good configuration that it can take our complete network. We have to take care of the complete instance. That it means that we have to make sure that it allocates, and it can take a huge amount of traffic and can scale. We have to take care of the scaling of the traffic. We have to take care of degradation of the scaling. So all that part we have to take care of, but which can be a headache, because you have to maintain 2 machines now. One is the instance and one NAT instance, and one is the private instance. So that's why that is completely eliminated or not recommended, and we use a NAT gateway instead of NAT instances. So that NAT gateway, you don't have to manage the NAT gateway. The AWS will take care of the stuff, and they will take care of this complete thing. Okay, so that's what the NAT gateways are there. So we have NAT instance and NAT gateway, and then you have both Bastion host or jumps box. You call them Bastion host or jump box. What is that Bastion host or jump box? Let's say you have a private subnet, right? And that private subnet is not going to be accessible outside from the anywhere outside from the world, right? It's in the private subnet. But there can be a possibility that, let's say, I'm sitting outside over here, right? I'm sitting outside on, let's say I'm sitting outside the VPC. My machine is outside the VPC, and let's suppose that I want to do an SSH in order to do some changes manually or to do some configuration on a private subnet. As I'm sitting outside the outside the VPC, and I will come through the internet gateway, right? If I even try to get into a private subnet, I won't be able to do that, because that's a private subnet. The route table which are over here will restrict me to access the private service instances or private subnet instances. Okay, those will be restricted. So what happens if really wanted to access the instance which is inside a private subnet? So I cannot access it directly, right? I have to, if I wanted to access it, I need some mediator in between to access a private subnet. And to do so, what I can do is I can come like this way. Like one way is that I do a login with a subnet, public subnet. Okay.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
With I do login with I do SSH on the instance of public subnet, and on a private subnet, because these two can communicate with each other. So I have to come to a public subnet of this instance, and from this instance I can jump into this instance. Okay, one way of doing is this. Okay, so when have a scenario where you are outside the network and you wanted to access a private subnet machine, you will first have to access this public subnet machine which is there on the security group, and from there you will after you will go to the private subnet instance. Okay, and that's what you will do. And in all that case, that particular public service instance which I'm taking as a I have to log in and then to in order to access the private subnet, that is will be called as jump server or a bastion host server. This is not necessarily that you create only this instance. Sometimes in a scenario, in a real life scenario, we have a different instance that is been in a public subnet, and people around outside the world or people outside the VPC, they first connects to that bastion host server, or that is nothing but a EC2 instance which allows you to communicate, or is a mediator which allows you to get into the private subnet. Okay, so that is a bastion host or a jump server. So jump server is nothing but an instance which is there in a public subnet, allows the outside users to do on them. And once you have a proper SSH on bastion or a jump server, you will be allowed to have an access of private subnet instances in order to do a modification and their configurations. Okay, that's what a bastion host or a jump server stands for. Okay, let's go back and see, do we have a now we have a VPC created automatic, created over here. So if you see over your VPC, okay, so we'll have a VPC over here. Let's see, let's wait for that to come up. Okay, on the top you see that there's a Sony VPC has been created, which is like this. If you click on the VPC ID, you can see that this is a CIDR block which has been allowed, and then flow logs, tags, and so on. Okay, so now we have a VPC ID, and this is a VPC ID which is named as Sony Day 1. We'll have subnets as well. So if we click on subnets, we will have two subnets. Public subnet over here, and both are associated with the same VPC ID. See that you can copy. Sorry, we can copy that VPC ID to see what all VPCs has been associated with. Okay, so let's just copy this VPC ID. Go back to your subnets, paste it over here, enter. You will see there are two subnets actually associated with this VPC ID. One is called private subnet, one is called public subnet, right? This is what we created. And if you see the public subnet, um, you see the public subnet, there is a associated with to them. Okay, that's a route table, and there's an internet gateway attached. Okay, but same if you see a private subnet, you see a private subnet, on the route table you will see there is a NAT gateway attached. Okay, so that it takes the outcome. So it has been associated with NAT gateway, where this public subnet is associated with internet gateway. IGW shows you this is an internet gateway. Okay, so all whenever we create an instance and we selected this subnet, that means the instances created under this subnet will be able to access the internet, that will be able to have an internet gateway attached to them and will be able to access the internet. Okay, on private subnet, we'll have to see that this is associated with the NAT gateway. We cannot do a login directly to it, but we have to come first to the instance of a public subnet, and then on a private subnet we can jump in. Okay, then if you see a public subnet, we have a network ACL. Okay, and you see the network ACL has been, it says that 100 is allowed, all traffic is allowed on inbound thing, and all is been allowed on outbound as well. Okay, similarly on private subnet, if you see the network ACL, you would see that it says allow and deny on this as well. Okay, so if you have any you want address which you wanted to block on, you can add that IP address over here and you can say deny. Okay, you can say set the rules on this. Okay, so now we have two subnets which has been associated with the VPC. We'll also have some, we can go on route tables. If you write that VPC ID, you write it over here, you will see the route tables as well. So that VPC, and when you hold to subnet over here, like to a route table, one will be specifically dedicated on to the private, one will be specifically dedicated to the public. Okay, so when we come back, okay, so we have a public route, we have a VPC, and all is started, which has been attached to it. Okay, so that's what the VPCs are, and you need to know them very well, because you might need to block sometimes. Oh, one more thing over here, you will also have a security group to that VPC. If it's not there, you can create one. Yeah, over here you see the security group. Also in the security group, if you just scroll it up, you can see that it's been associated with this. You have an inbound rule. Okay, all traffic of the security group. You have outbound rules. Okay, which goes in and come in, right? So that is there. Now, for example, if you wanted to put an instance on different public subnet, or which it is on, you will go to EC2. I'll show you how you put that. Let's create an EC2 instance, and when you create an EC2 instance, it will ask you for, okay, we'll select a VPC which we have created, and in a VPC when you select a VPC, it will ask you to create a we have a 2 running.
Thanks for watching. Want to study further? Join our training programs today.